Hi everybody, in this video we're going to calculate a t-value for the independent samples t-test. So I'll show you again the equation and walk you through how to actually calculate a t-value with some raw data. So let's imagine we've got a scenario where we have two independent groups and we need to compare the means for those groups. So in this case, let's say that we have two versions of a pamphlet on something like fire safety. It doesn't really matter. This is just for illustration purposes. And let's say we want to see which version of the pamphlet is more effective at teaching people about fire safety. So we have one version, the red pamphlet version. We randomly assign these 7 people to read the red pamphlet version. We then have them take a quiz about fire safety and see how they do. And this is their score on fire safety. Then we have other people that we had randomly assigned to the green pamphlet group, and they read that version. So here are those 6 people, and we have them take the same quiz about fire safety to see if they do any better than the people who read the red pamphlet group. So really quickly, we have independent samples here, a dichotomous independent variable, which is which pamphlet they read, and then we have a continuous measure as our dependent variable, which is of course the quiz score. Let's say it's out of 10 or something, it doesn't really matter again. Okay, a couple of things to note here. First of all, you'll see there are 6 people in the green pamphlet group and 7 people in the red pamphlet group. Is that a problem? The answer is no, that's not a problem. That's the short answer anyway. In a perfect world, I would prefer to have at least 30 people in both groups, but just for the sake of time, we'll keep the samples small here so that we're not here all day doing math. Okay, so 7 people in one group's a little bit small anyway, so 6 and 7, however, isn't that different. And so no, I would not be worried about that. If it was 10 and 3, now I'd be a little worried because 3 is a very small number to have. But it doesn't actually matter that much as long as they're relatively close to each other. All right, so now let's see what we need to do here for the t-value. Okay, once again, you'll see that this is the t equation. If you don't recall any of this, just look at that video where I introduced the t equation for the independent samples t equation. We've gone through all of these symbols. So here's the same data that I had from the red pamphlet group and the green pamphlet group. Now, one of the first things we're going to need to do is, of course, square all of the values from each group. So this is, of course, group 1. As you recall, the subtext indicates that this is all of the values from group 1. And then we square each value from group 1. Same thing for group 2. We'll need to do that over here. I just like to have these little columns here to help me organize. Also, we will need to know the sums of many of these values, and so I add an entire row down here to help me obtain everything that I'm actually going to need to plug into the equation. And if you take a close look, you'll actually see that everything we need to solve the t equation will be right down here. Once again, a reminder here, sigma means the summed up values in this particular case because this is group 1's values. This is the sum of the group 1 values. So we're simply adding all those numbers up. And as you can see here, this will be the total number of people in group 2 or total number of observations. This one's the total number of observations in group 1. All right, things like that. So let's go ahead and do that. One of the easiest ones, of course, is this. So we'll start off with the number of people that we have. We have 7 people in group 1. We can do the same thing for group 2. We have 6 people in group 2. So n sub 1 is 7, n sub 2 is 6. You can see where to plug those in. There's n sub 2, n sub 1. No problem. Let's move on. We'll sum up all of the x scores from group 1. In other words, these are the quiz scores that we observed. Those are dependent variable. We add all those up and you get 32. If you don't believe me, pause it and use a calculator. We'll do the same thing for group 2 over here, add up all of their scores to get 41. Now let's pause for a moment and look at this. So sigma x sub 1 goes right here in the equation. So 32 we will just plug in right there. And 41 we will plug in right there. I do that in a couple of minutes here, though. I'll show you where to plug all those in. Okay, we'll keep going. While we've got the 32, a very quick thing we can do is get the mean, right? This is, again, the bar always cuts off when I do a PowerPoint slideshow. I don't know why that is, something to do with Microsoft. Anyway, so we can easily get the mean by doing 32 divided by 7, which is 4.57. You'll recall as we talked about in central tendency, that's how you get the mean, is you take the sum, divide by the number of observations you have there, and then you get the mean. We can do the same thing over here for group 2. 41 divided by 6 is 6.83, and it goes on. I've rounded just to do 2 decimal places, which is usually fine. All right, Then we square each of these values. 4 squared is 16, 7 squared is 49, 5 squared is 25, and so on. I add up all of those squared values to get 162. Do the same thing over here for group 2. 5 squared is 25, 6 squared is 36, 7 squared is 49, and so on. Add up all of those squared values to get 291 as our sum of squares. And as you can see, again, that value is going to go right here. This value is going to go right here. All right, now let's plug these into the actual equation. Then all we do is simplify the equation. So here's the equation, again, the original one, and I've now taken just those bottom two rows from the table I had in the previous slide, and I've moved them here just for simplicity's sake. Now that we can refer to them, you can see all the symbols are still there. Now, if we plug them in, it looks like this. So we have the mean of group 1, which is 4.57. That goes right there in the numerator. The mean of group 2 was 6.83, goes right there. You can see we subtract, right? Okay, the total, sum of squares, for group 1 is 162. That can go right there. The sum of the variable was 32, which goes right there, right? And then we had 7 observations, which goes right there and right there. Same thing, the sum of squares for group 2 was 291. 291 goes right there. We had a sum of the variables, which is 41. 41 goes right there. We had 6 observations of the variable, which of course goes right there, and right there. Oh, I didn't mention that group 1's number of observations also goes right here. Anywhere there's an n sub 1, ed sub 1, ed sub 1, that's where your 7 goes. Okay, so we plugged everything in. Now we just need to simplify. So I've just moved that last equation over here now so that we can refer to it and you can see what I'm doing. Again, order of operations matters here. However, we can combine some steps into one section here if they don't affect each other, right? So we can easily square the values here that we have. That's one of the first things we can do. And in the numerator, there's nothing to do except subtract, so we might as well go ahead and do that. So here's what this looks like. If we subtract 6.83 from 4.57, we get negative 2.26. Now, this will matter more in the interpretation, but the sign doesn't really matter in this case, as long as you recall which group had the higher mean. In this case, we can note here that the higher mean was the green pamphlet group. So we just need to remember that in our interpretation later. All right, once again, we square 32 and we get 1024. Some people get confused here, and they think that squaring 32 gives you the same as the sum of squares, which is 162. And as you can see, they're very different. 1024 is not even close to 162. So please don't mess that up. 41 squared is 1681. While we're here, we might as well also divide these. 1 divided by 7 and 1 divided by 6 are respectively 0.14 and on. I've rounded only to the first 2 decimal places, and 0.17, okay, as I said. All right, 7 plus 6 is of course 13. 13 minus 2 is 11. So that's everything right there. Now let's do another step. I've just moved exactly what we did to the top of the screen now so we can continue on. Next thing to do, of course, we're starting in the parentheses, right? And so we're going to divide here, and we might as well just add those together, no trouble. Okay, so 1024 divided by 7 is 146.3. 1681 divided by 6 is 280.2. Here's a quick note to check your math on your homework. If you ever get to this point and this number is larger than this number, you messed up. You made some mistake somewhere and you need to go back and figure out what you did wrong, because that's not possible. Same thing over here. If this number is ever smaller than this number, you messed up. That's not possible because you can't take the square root of a negative number, and you may end up doing that is potentially possible if you get a bigger number here than here. Okay, so it's not actually physically, mathematically, I should say, possible to do that. So check your math if that ever comes up. All right, nothing else to do right here. We can't move on any further with that until we figured out what's in these brackets. Nothing to do in the numerator. So let's go ahead and move this to the next slide. All we do now is subtract here, right? Subtract 146.3 from 162 and 280.2 from 291. This is what we get, a difference of 15.7 for group 1 and a difference of 10.8 for group 2. Once again, we're talking standard deviations so far. We will add those next and then divide by 11. Okay, once again, I've just moved that equation right here. All we're going to do here is add 15.7 plus 10.8, which gets us 26.5. Now I've stopped the color coding because this was information strictly from the green pamphlet group. This was information strictly from the red pamphlet group, but now they're combined. Okay, these are now pooled together, and so I'm going to stop using the color coding. All right, so at this point we divide 26.5 by 11, as you can see right here. And so this is what we get so far. Now let's hang on for just a second, because this item, if you'll recall from the t equation lesson, is the pooled standard deviation once we take its square root. We don't need that at the moment, but we will need it to do some fancy things later. So I just want to make a note here that this is how you get it. You take the square root of 2.41 to find your pooled standard deviation. Of course, in this case, it's 1.55. So we don't need that right now, but we're going to write it down and we're going to save that for later. Now, I hate to bring it up here because now some people get confused and they think it's 1.55 times 0.31. That is not true. You already took the square root of 2.41, right? That's just how you get the pooled standard deviation. But that's without multiplying it by this. So now we've left 1.55 off to the side. It's on the back burner now. Now we come back to our equation and we continue on. So now we need to multiply 2.41 by 0.31. Then we'll get the square root of that. So here's how we do that. 2.41 times 0.31 is, of course, 0.747. We still haven't taken the square root of that product, so we're going to do that now. The square root of 0.747, and again, I've rounded, is 0.864. And now the last thing to do is divide negative 2.26 by 0.864, which is, of course, negative 2.62. Okay, now at this point, you're saying, whoa, we've got a t-value of negative 2.62. I have no idea what that means. That's fine. We're going to get into that in the next couple of videos. Okay, so hang on to your hats. We're going to figure out whether this is an important t-value, whether it matters, which pamphlet then we should start using if it matters. So we'll cover all that next in the next few lectures. Thank you. I'll see you then.